Hello everyone, welcome to my channel. I have already made one tutorial about MCP server with Spring AI. This is part 2 of this series. Before watching this part, I would highly recommend you to watch part 1 of the tutorial. In this part of the tutorial, we'll try to deep dive the workflow of MCP, especially the transport modes. From part 1, we already know that there are 3 transport modes: STDIO, SSE or server sent event, streamable HTTP. STDI is used for local MCP servers mostly. SSE and streamable HTTP are used for remote MCP servers. In this tutorial, we'll focus on SSE and streamable HTTP transport modes. In the SSE transport mechanism, the server runs as a standalone process and it can handle multiple client connections. The server should provide 2 endpoints, one SSE endpoint and one HTTP post message endpoint. The SSE endpoint is used by clients to establish connections and receive messages from the server. The message endpoint is used by clients to send messages to the server. Client initiates the SSE connection by calling the SSE endpoint. When the client is connected, the server sends an endpoint event containing the URI for the client to send messages to the server. The URI may contain the session ID. All subsequent messages from the client are sent as a HTTP post request. The session ID may be passed as a query parameter. Server messages are sent as SSE message event with the message content encoded as JSON. Client messages and server messages are sent repeatedly as a loop. So client will send HTTP post messages to server. Server will send SSE messages to client, and it will work repeatedly as a loop. Finally, SSE connection is closed by the client. Now let's show a demo using Postman. We'll use the same Spring AI project. Let's start the MCP server using docker compose up command. Okay, our MCP server has been started. Now let's call the HTTP endpoints directly using Postman and try to understand how SSE works for the MCP server. From Postman, let's call the get SSE endpoint. And this will initiate an SSE connection. An endpoint event is sent from the server. It contains the URI with a session ID. The SSE connection will remain open. You can see it is receiving a response from the server. And if we check the headers, the content type is text event stream and the transfer encoding is chunked. At first, the client will send the initialized message. We need to use the same session ID. Let's pick the session ID. This is a notification message, so there will be no response from the server. As the second call, the client may ask for the list of tools. The session ID will remain same. The request body will look like this. In the SSE connection, there will be a message from the server this time, and this message contains the list of tools. You can see the list of tools is in the message, and it contains the list of tools, and it contains the input schema for each of the tools. And the whole message is in JSON RPC format. The client can call or execute a tool now. The request body should follow the input schema. it should provide the required parameters. Now the SSE message will contain the result of the tool execution. So as a result of the tool execution, it has returned the weather forecast or alert. So the message is also in JSON RPC format. And when the same mechanism is used with a AI host application like Cloud Desktop, this result will provide additional context information to LLM. Now we can terminate the session. Let's discuss another interesting point. The latest version of Postman now supports MCP as a separate protocol. So we can test MCP protocol directly from Postman. So we can create a request using the MCP protocol directly. And we can choose the transport mode. And as the request, we can use the SSE endpoint. So a session has been created, and we can see in the message the tools, prompt, resources, these are shown here. So in separate tabs, and these are the server features, also known as primitives. In the tools section, we can see the list of tools are shown now, and we can even call a tool. So if we run it, it will return the result or response from server, and we can also terminate the session. As of today, streamable HTTP transport mode has not been implemented in Spring AI. So I cannot show any demo of it, unfortunately. We can still explore the workflow and understand the concept. Hopefully the Spring AI team will implement it soon. Before exploring the streamable HTTP, let's think about the drawbacks of the SSE approach for a moment. You can pause the video for several seconds and think. Let's continue the discussion now. What are the drawbacks of SSE transport mode? The first one is long-lived SSE connections. Servers need to maintain long-lived connection for each client. This causes significant resource consumption. The next one is no support for reconnection or recovery. When an SSE connection drops, all session states are lost, forcing clients to re-establish the connection and reinitialize the entire session. The next one is messages or server messages delivered via SSE only. Even for a simple request response interaction, servers must return information through the SSE channel. This causes unnecessary complexity and overhead. Now let's explore the workflow of streamable HTTP transport mode. Instead of two separate endpoints, an unified HTTP endpoint has been introduced here. This unified endpoint supports both GET and POST methods. Let's begin with session initialization. Clients send initialization request via POST method. Server may generate a session ID and return to the client. Session ID generation part is optional. Session ID must be generated if we want to keep the connection as stateful. If we want to keep the connection as stateless, then we can skip the session ID generation part. Afterwards, the client sends the initialization notification. Client to server messages. All messages from client to server are sent via HTTP POST request to the message endpoint. If the session ID exists, it should be included in the request, otherwise it can be skipped. Server response methods. For servers, we can choose between two options, either standard response or streaming response. For standard response, server would return a direct HTTP response. This is suitable for simple interaction. For streaming response, server would upgrade the connection to SSE and send a series of events and then closes the connection. Server needs to maintain a long-lived SSE connection for the continuous event delivery. The SSE event can be also initiated by the client. Client can initiate the SSE stream with an empty GET request to the message endpoint. Servers can send push notification or messages through the SSE stream. Regarding connection recovery, if the connection drops, the client can reconnect using the previous session ID. Based on the session ID, server can restore session states and it can resume the previous interaction and communication. The streamable HTTP transport mechanism is a significant improvement of the MCP protocol. It combines the strength of HTTP and SSE while overcoming their limitations. It provides a more flexible and reliable communication solution for LLM applications. It not only addresses the issues of the original transport mechanism, but it also lays the foundation for future improvement. That's it for today. Hope you enjoyed the tutorial. Thanks for watching.